Our study of logic and truth tables will really come to fruition here in section 3.7, Arguments and Truth Tables. Here we will learn how to use truth tables and the rules that we have discovered to analyze whether logical arguments are valid or invalid. We're going to study a specific form of an argument called a syllogism. Now, a syllogism is a type of argument consisting of two or more given statements called premises, followed by a conclusion. So in a syllogism, you have a series of statements making assumptions and stating facts, and these lead you to a specific conclusion. The last statement in a syllogism is a conclusion. Now, I mentioned before that Lewis Carroll wrote Alice in Wonderland, and if you go back and watch the movie or you read the book, you're going to hear all kinds of syllogisms as part of the dialogue in that book. Here's an example of a syllogism. If I study for the test, then I will get an A. I study for the test, therefore I get an A. This syllogism is composed of two premises and a conclusion. The major premise is the first statement. If I study for the test, then I will get an A. The minor premise is associated with the major premise. I study for the test. And the conclusion is, therefore I get an A. Now, an argument is valid if it is a tautology. Remember, a tautology is always true, a statement that is always true. A valid argument has good logic and correct reasoning. So when we say that an argument is valid, we are assessing the logic and the reasoning to be correct. Don't confuse the words valid and invalid with true and false. The word valid simply indicates that the reasoning is correct. It does not guarantee that the conclusion is true. So let's look at a couple of examples to illustrate this contrast. Example 2. Some arguments may have true premises followed by a faulty conclusion. The following argument is invalid. That means it has incorrect reasoning, even though both of the premises are true. So let's read the syllogism. All carrots are orange. Some cats are orange. Therefore, some cats are carrots. Now, look at the major and minor premises. All carrots are orange. That's true. Some cats are orange. That's true. Therefore, some cats are carrots. Well, that is a faulty conclusion. This is incorrect reasoning. Observe here that we have an argument that contains quantifiers. Now, if your argument contains quantifiers, you can discover the validity of the argument using something called an Euler diagram. An Euler diagram is just another word for a Venn diagram. It's a way of visually representing the relationship between these premises or sets. The major premise is all carrots are orange. So let's look at a set of orange things. Okay, so inside this circle, we've got things that are orange. All carrots are orange, so the carrot circle has to be completely within the orange circle. Now, some cats are orange. Now, cats can be orange, but we know cats are not carrots. So we're going to construct the cat circle so that it overlaps the orange circle, but not the carrot circle. So both of our premises are correctly illustrated on the Euler diagram or the Venn diagram. Neither has been violated. Now we can test the conclusion. Therefore, some cats are carrots. Well, if the cat circle also overlapped the carrot circle, then that would be a valid conclusion. But we've been able to construct this Euler diagram in such a way as to illustrate the premises correctly, but find that conclusion to be faulty. So this is an invalid invalid argument. It is an invalid argument and it has a false conclusion. Let's contrast that with the next example. Example 3, an argument may be valid because the reasoning is correct, but the conclusion might still be false. The following argument is valid, but the conclusion is not true. Let's see if you can spot the flaw in the argument. Major premise, all doctors are men. Minor premise, my mother is a doctor. Conclusion, therefore, my mother is a man. Now remember, this is a valid argument. That means it has good reasoning. Good reasoning and a valid structure for your argument does not necessarily mean that the conclusion is true. Let's draw an Euler diagram for this one. So our universal frame of reference will be within this rectangle. All doctors are men. So let's suppose that within this circle we have all points representing men. Now, all doctors have to lie within that set according to our major premise. So the doctors are completely enclosed in the circle of men. My mother is a doctor, so she is an example of a point in that circle of doctors. And from the Euler diagram, I can see that mom is also within the men circle. Therefore, my mother is a man. This is a valid argument, but it has an absurd conclusion. So the argument, the reasoning is correct, but we have a false conclusion. So make sure you understand the difference between valid and invalid and true and false. Valid and invalid describe if the reasoning is correct or incorrect. It's telling me about the reasoning in the argument. But it's possible to have a valid argument and a false conclusion. Now, the reason we were able to illustrate these with the Euler diagram is because we had these quantifiers. For the focus of this particular section, we're going to be examining arguments that are composed of statements with connectives, not, and, or, if, then, if, and only if. To test the reasoning there, we're going to need our truth tables. We'll examine that in the next section.